Okay, I want to talk about friction, and I'm going to use this force cart to push it until it starts to make this block slide. So we have the friction force there, and we can measure the force that we push it with. Let's just go ahead and start collecting data. I'm going to start pushing it. So you may notice something kind of important. It's not super easy to see, but as I increase the value of the force pushing on the block, it didn't move until this point right here. And then it jumped down. So there's two things here. One, the frictional force due to static friction is not one value. It's less than or equal to. It's a force of constraint. It's whatever it needs to do to make the block not move. But then once it does slide, that frictional force drops down. And so I don't push it with the constant force, so that makes it a little bit difficult. But you can see that the kinetic friction force is less than the value. Okay, so up here we have the model for static friction force. The static friction force is less than or equal to the coefficient of friction times the normal force. So the normal force is how hard they're pushing down together. So this is a problem a lot of students have difficulty with because they wanted to say, oh, friction is equal to the coefficient times the normal force. That's not true. The end. Friction is really complicated though. Okay, but this is a model that works in a lot of cases.